Welcome to this video about separable differential equations. So what is a differential equations anyway? You know, in a regular equation, something like 2x plus 4 equals 8, we can solve this easily for x and then see that x is equal to 2. But for, let's say we have something of an example where we have a water tank which gets distributed water at some rate, and at the same time water is flowing out, let's say into a pool, and at a rate, let's call it R2. How much more water must I distribute here to maintain this? In these cases, or what is the connection here? In these cases, we can use differential equations to solve these. So differential equations gives us then sort of a connection between a function and its derivative, its rate of change. What is the rate of change in this tank? Right. So there are many types of differential equation, but as mentioned, we'll look at the separable ones. So there is a neat algorithm here. So our first point is, how can the separable differential equations even be written? So you can use either the Newton notation, which is y, and then some, let's say it's called y primed, that's what is most usually called. Or you could use the Leibniz notation, dy dx. And I can already tell you that this notation, dy dx, is much more smarter and much more helpful in differential equations. So I always use them. But yeah, back to the separable ones. We have two functions. We have a product of the function on the right side of two functions here. So we have g of x, one function, and then h of y. So this is a product of two functions. So what do we want to do to solve this? We want our x's on one side and our y's on the other. So how can I achieve this? By writing it again, dy over dx is equal to g of x times h of y. I want my x's on the right side and y's on the left. So I can achieve this by multiplying by dx and then dividing by h of y. And then it would look like this, since it would look like 1 over h of y dy is equal to g of x times dx. And then we can now integrate both sides. So I get the integral of 1 over h of y dy is equal to the integral of gx times dx. And by doing this, we will get the antiderivative of both sides. Let's call the antiderivative of our left side capital H of y. And of course, we will get a constant. That's how integration works. If you have nothing, you will always get a constant because the derivative of constant is 0. So by doing the anti-operation of derivation, basically, we will then get a constant on our capital of gx, and we will get another constant here. Let's call it c2. And our final step, we want h of y by itself. So we get h of y is equal to g of x plus c2, and then the c1 goes over and then changes, so we get minus c1. And this again can be written as a new constant, c3. And here we are. So this is like the basic algorithm how to solve a separable differential equation. So let's look at an example. So dy over dx is equal to 3x times y. So immediately we have dy dx on one side, and our g of x here would be 3x, and our h of y is just plain old simple y. So, first step, multiplying by dx and dividing by y. So we get y's on the left side and x's on the right, which will then give us 1 over y dy is equal to 3x dx. And if people write dy over y, it's the same thing as writing 1 over y times dy. I just like it this way better. Now our next step, we could now integrate on both sides. So 1 over y dy is equal to the integral of 3x dx, which will then in turn give us, so remember from your integration classes, integrating 1 over some constant or some variable rather, here y will give us the natural logarithm of the absolute value of that variable. So, okay, we've integrated the left side. How about the right side? We can here use the power rule. So, we will get the 3 stays unchanged. So we get 3, and then x becomes x squared, and then we divide by 2. Of course, I forgot the constant here. And then the constant here. Okay. Now we have done everything the algorithm says, but this isn't really a solution, right? So with these, the beautiful thing with the ln ones is we can take everything here to the power of e, and then of course the absolute value of y is equal to e to 3x squared over 2 plus this new constant. Let's say I already did this, minus c1. Whoa, this becomes c3, beautiful. So, plus the c3. And the beautiful thing here is that I can just erase these, because that's how it works. It's just beautiful. And then, in turn, I will get the absolute value of y is then equal to e to the 3x squared over 2. And remember, this is powered up. So, using the power rules, we will get then times e to the c. This is the same thing as the plus c up here, and then let's just call c3 c for now. And here, just to make it even easier, e to c is just some random constant. So I just notate it by saying it's called c. And now for our final step, to remove the absolute value brackets. So I can say c is equal to, and if I put this c in front, I will get y is equal to c e and then 3x squared over 2. And this is said to be our general solution. Perfect. Now, let's say I was given an initial condition to this differential equation. I was given something like, this is rather useful for these kind of examples, that y of 0 was equal to 6. So, okay, that's awesome. I was given this. Okay, then I can find a special solution to this differential equation, because this general solution, okay, it works for every differential equation that it looks like this. But here it is taken a step further. So y to the 0, what does that mean? It means when x is 0, or of course when y is 0, the function is equal to 6. Okay. So the thing is that all these constants I was given. So for this general solution, this c is just is stands here, right? But when I'm given the initial condition like so, I can then solve the c and get a special solution. So if y0 is equal to 6, then immediately if y is equal to c e to the 3rd x squared over 2. I can now plot in for x equals 0. So we get y is equal to c e to 3 times 0 to the power of 2 over 2, which then gives us c e to the 0. And we know that any constant or variable, whatever, to the power of 0 is equal to 1. So we will get e, or rather we will get y is equal to c times e to the 0, which is c times 1, and we remember this must be equal to 6. Therefore c, we just move it over, c is then equal to 6 divided by 1, and then c is equal to 6. So our special solution here will be y is equal to, now c is 6 times e to 3x squared over 2. And this is our special solution.